Jai Sri Ram friends. So today we will understand topological sort. So topological sort is like the scheduling of tasks in which like one task depends on the another. Like suppose in construction of bridges, we will bridges or pillars, we will or flyovers, we will first construct the pillars. Then we will build road on it, right? So likewise topological sort. Like we have to complete one task before moving to the other task. So as you can see in this graph, directed graph, that 0 will be done only after 3, 2 and 1, because 2 is directed towards 0, right? So it means that 0 can only be done after 2. That what's like a directed graph represents. Uh, Basically directs towards that. So if you assume or suppose this is some task 0 1 2 3, these are all some tasks, but 0 can only be completed when 3 is 2 and 1, these three are completed, then only we can complete the 0. So that's where topological sort come into picture. We sort in the order by which the task should be completed, right? So let's start with the adjacency list. So adjacency list would be simple. For 0 uh, to which it is directed to, no one. 1 what to is directed to, 0. 2 is directed to, 0. 3 is directed to, 0. Okay. Now let's one another thing which is required for doing a topological sort is in degree, because we need to find out who have like what is in degree first. Let's understand what's in degree. In degree is nothing like how many, you can understand in simple language, is how many tasks are directing toward it. Suppose if I ask about 0, 0, how many tasks are directing towards it? It's 3, right? 1, 2 and 3, right? So this have in degree of 3. How many tasks are directing towards 3? It's 0, right? No one is directing towards 3. So 3 can be completed first, because no task is directing towards 3. So 3 doesn't have any prerequisite. So that's the in degree. In degree basically depends how many tasks are directing towards you. So 3 have 0 have 3 in degree, 3 have 1 0 in degree, 1 have 0, 2 have 0. So let's have in degree. So in degree for 0, 1, 2 and 3. First all we have 0, 0. Then we like loop through this adjacency list, and we mark the in degree when we move from move in one vertices in the to the right of this the array, which like what is adjacency list, the it contains the array, right, to which it is directing to. Like if one is directing towards 0, if suppose it's if one is also directing towards 3, so in adjacency list we will have 0 comma 3, right, for one. So that's what the adjacency list is represent. So when we move down this adjacency list, we will mark as the in degree of the right side which it is pointing to, right? So what will be the in degree in here? As you can see, for 1 is directing towards 0, so it will increase by 1. Then it is 2 is also directing towards 0, then it will increase by 1. Then 3 is also directing towards 0, so it increase by 1. Okay, so we can see that in degree of 0 is 3, but all other vertices have no in degree, right? So here also one thing to note, then if these three have no in degree, then answer can be multiple, right? uh, it because if in degrees, if three vertex in a task have in degree 0, means they have no dependency on other tasks, anyone can be completed first, right? Like you can complete first, then third, then second, then second, then second, then third, or you can complete third, then first, then second, right? But point to be noted that 0 cannot be come in between, right? First we will complete that tasks which have no independability, and we will remove them. like if we remove these three tasks, like uh, 1 is completed, 2 is completed, and 3 is completed, then 0 will be left with no dependability. Then we can use, then 0 will have 0 in degree, right, if these three tasks are removed. So to solve this, we use adjacency. We use a queue in which we push this. First, we will start with those numbers, those tasks which have 0 in degree. So at first, we will push all the numbers like which have 0 in degree. We'll start with 1, 2, and 3. We will push all the three, and then one by one, we will remove that, complete that task, and we will add it into our answer, right? And like first, we will remove 1, then and we will reduce the dependency on the on which it is dependent, right? If I remove 1, the zeros in degree will be reduced by 1, right? Then I will reduce 2, then I will remove 3, and that's why, and it goes on. So this is what happens. Let's look the code quickly. So first we will have an in degree array with initialized with 0. Then we will have the topological sort answer, in which it is the way it is sorted. Then we will have we will loop through the adjacency list, right, to mark the in degree. What are the vertices pointed to that vertex? Then we will have that queue, and we will push it and start with that vertices which have 0 in degree, right? So which have no dependability. Now we will move next, and we will loop. We will remove one by one the vertex from the queue, and then we'll push into this answer. Will the topological sort order, and then we uh, we will also remove that dependability, right? If you remove like I have shown you, right, in if we remove 3 from that, so zero's dependency will be reduced by 1, right? So its integrity will reduced from 3 to 2. So it's reduced, and you will check it now. Is it any other vertex whose integrity has become 0? Then it will next be pushed into the queue. So this, as you can see, like test cases are fast, and this is the topological sort. Thanks for watching.